It is important to invoke SCAT at the right time and place. The module examines the phases of an oil spill and where and how the SCAT process fits. This includes the initiation of SCAT from response using local resources. Then later, when an incident management team residing at command post has been established. The role of the environmental unit in SCAT delivery management is discussed, along with key SCAT positions and tasks. Of particular importance is explaining and differentiating SCAT field personnel based on those hired as specialists compared to those provided as an agency, First Nations, or other representative. This is a dynamic and fluid arrangement. The end of this module explores why, where, and how to prepare ahead for undertaking a pre-SCAT field program before an oil spill. An example is provided. This module takes about 40 minutes to complete.
Let's look at where SCAT fits within different phases of an oil spill. The first phase is the emergency or reactive phase. This is when oil is still on water and spreading. One of the first things you do in SCAT is to be engaged in aerial reconnaissance, either undertaking it yourself or working with the aerial observers. This is part of getting ahead of the curve. In order to set up a shore protection program, which includes SCAT, it's important to know what shorelines are oiled or are going to be oiled. With this situational awareness, you'll be able to determine how many SCAT teams you will have and their logistical needs. Within the context of a shore protection program during a marine oil spill, it is the emergency or transitional phase that is least understood. This is where mobile oil has trapped within the shore zone, within crevices, channels, and behind islets and amongst kelps. This is still an emergency phase, as the oil is still floating in the water and is spreading. The objective during a transitional phase is to shift response focus from reactive offshore oil recovery towards a systematic shoreline cleanup to recover this oil before it strands on shores and becomes an expensive, protracted work effort, and before this oil also becomes covered by sediments. This again is part of getting ahead of the curve. The last phase of an oil spill is what I refer as the project or protracted shoreline phase. This is where there's no more re-oiling of the shores. It's now a work project of gathering field data to guide long-term cleanup of oil shores. The phase is systematic. It's undertaken on a shoreline segment-by-segment basis. SCAT teams are fully deployed and getting ahead of cleanup workers for gathering information to develop oil shoreline treatment plans if required. It essentially becomes a prolonged job for SCAT and operations to work separately but collaboratively. It is the protracted work phase that most SCAT courses, as well as this one, focuses on. When does one initiate the SCAT process? Ideally, it's in the emergency phase, both during the reactive offshore oil recovery and during the transition phase when oil is now trapped and gathered along within the shore zone. This is where these field observations as a reconnaissance or field level of aerial flights are undertaken to gather a real common operational picture. This is also the time and place in which Tier 1 local response capability comes into play, such as deploying nearshore response booms and undertaking these kinds of aerial observations. At this phase, Incident management, such as under incident command system and establishing an incident command post and an incident management team therein, has not been established. Once an incident management team has been established, the SCAT process is now undertaken according to the incident command system's processes, such as complying and working according to its operational period, which is a series of meetings and actions and deliverables done on a day-to-day basis, and establishing a daily incident action plan. As such, it's very important that a SCAT member has a full understanding and experience in the incident command system. Once an incident management system has been established, such as the internationally proven and applied incident command system, the SCAT is managed within the planning section's environmental unit. Within its unit, the supporting functions of a SCAT, or a shoreline protection program, are collecting field data through systematic surveys in real time, documenting field data in maps, tables, and forms, managing field data that supports planning, operation, command decisions, and advising operations, command, and others on SCAT process, products, and validity. This is a very dynamic and engaging unit to work within. Generally, you're working as a working group, but you're also working overall as a team. Your daily assignments will be developed by the SCAT coordinator, sent up the command chain through planning sections to unified command for approval, then packaged as part of the daily incident action plan. There is certainly a lot of work that a SCAT member must undertake. Let's look at some of the tasks that must be done. First, there's identifying sensitive ecological and cultural resources at risk. This is usually a map exercise as well as supported by field observations. Then you are out in the field on an oiled shore, mapping the character and distribution of the oil, such as documenting the stranded oil's conditions as its thickness, spread, and weathering state. From there, you're making recommendations on cleanup based on best management practices. As well, to establish a net environmental benefit, you're establishing operation constraints so as to reduce additional ecological and cultural harm from the actual treatment or cleanup efforts. Throughout the course of an incident, you will be liaisoning with operational supervisors to address issues and concerns they raise in their work orders, as provided in shoreline treatment recommendation forms. As well, you will be determining whether or not endpoints have been reached and whether no further treatments are required. All the SCAT information that you gather in the field and the work process must be compiled, analyzed, and communicated to guide tactical operations and to command on the best course of action to manage stranded oil on each shore. And this is done by shore segment at a time. Let's look at the SCAT process schematic here. It shows that SCAT is somewhat forms and process driven. Let's begin with the shore oiling conditions, whereby you're a part of a SCAT team that has been assigned to a specific shore to assess for its oiling conditions, what kind of cleanup methods are going to be used, if any, and what would be the endpoints that when no further treatment would be required. You would be completing a shoreline oil summary form and biological form and maybe a cultural form, and taking photographs as you're gathering data, such as measuring the amount of oil that's on shores, its thickness, and its compositions, which is a more advanced level of training. You've arrived back to the incident command post and you provide your information for quality assurance, data analysis, and from that information within the environmental unit, cleanup recommendations are made and their summaries and tables and maps are developed. And all that information is communicated to tactical operations and planning, and then an action plan or cleanup instructions are provided. And those cleanup actions are provided to operations back in the field. And you can complete this process for every shoreline unit that has been oiled and that you are assessing. Let's look at the SCAT dynamics intensity based on working in the incident command post compared to working in the field. The incident command post is a very busy, intense area to be working in. This is where everybody has to work according to the operational period that defines scheduled meetings and deliverables that have to be presented on time. All the information has to be packaged and ready to be delivered, and then communicated to the unified command for approval, packaging needs an action plan, and as well the assignments then have to be communicated to operations. Their approved work assignments are then provided to the clean operations for what they're supposed to do for the shore that you assessed. In contrast, as a shoreline team member working out in the field, you get a chance to chill. You're going to spend a whole day undertaking assessment of a single shoreline. You got time to communicate, reflect on what you're doing, do collaborations. The goal is really just to have shoreline assessments a few days ahead of operations. At the onset of a marine oil spill, the first person that gets hired is generally a SCAT coordinator. This is a very highly experienced and trained person in the SCAT process. It's generally hired by the responsible parties, such as a ship owner, but is approved by a unified command. This is a very demanding position, for the SCAT coordinator has to scope out the number of field SCAT teams requirement, their logistics such as transportation, as well as manage what services that were required within the incident command post, like data analysis and packaging, such as the daily shoreline recommendation forms to guide operations. Ideally, the SCAT coordinator has participated in the aerial reconnaissance work, so has a very clear understanding of the situation and where the oil is going and what shorelines have been affected, what kinds of resources are vulnerable and sensitive to that oil. The SCAT coordinator also begins to build a understanding and a relationship with the local community, such as those that are undertaking businesses in the area, such as agriculture and ecotourism, as well as working with First Nations to gather their local knowledge regarding the resources and values needing protection. Within the Incident Command system, the coordinator will be reviewing the Incident Command's response objectives and start to reach out to operations to introduce their role of SCAT. And they will be working closely within the environmental unit and creating their own working group therein to establish a SCAT component within a shoreline protection program. Eventually, the SCAT coordinator needs to deliver a plan that provides an understanding of the work timelines and logistic requirements for SCAT. Let's take a look at what it takes to establish SCAT field teams. This endeavor is very fluid. It very much depends who's engaged in unified command, what resources and values are being impacted or threatened by the oil. There are two types of SCAT teams. There's a primary SCAT and a representative SCAT. The primary SCAT does most of the long-term field work and leads the SCAT field processes and tasks. These people are generally hired by the responsible party, like a ship owner, and they understand the SCAT missions and have some operational experience. The representative SCAT to work alongside with the primary SCAT in order to foster agency, First Nations stakeholder understanding and acceptance of the SCAT process and its findings. Those in the representative SCAT will work alongside with the primary SCAT members that may be coastal geomorphologists and biologists and archaeologists and those familiar with shore operations, they determine what kind of cleanup treatment methods would be required, if any, what would be the level of cleanup of the endpoints, and determining what constraints that would be required by operations so as they do no more further harms to sensitive and valuable resources. This interaction and collaborative process may be on an interim to a continuous basis. The objective is to foster a representative member's confidence and trust in the process of SCAT, its outcome, and to establish a sort of a social contract, which is a promise that this is the way the work will be done and accomplished by operations. This slide offers an interesting story. It is a mock-up showing representative SCAT working with the primary SCAT personnel. First observe there is oiling of vegetation shown at the bottom right of the image. So what are they doing? First, they are not measuring oil, they are actually talking. They're collaborating about something. The SCAT lead may be a qualified agency or person hired upon the response party who's very experienced in field SCAT. There could be a representative from the First Nations, a biologist from ecology or environmental department or agency. It may include a technical specialist like a geomorphologist, ecologist, or an archaeologist. This may be the first time they've ever met or the first time they've actually addressed oiling vegetation along a shoreline. So what they could be doing is calibrating. That's making sure that everybody's on the same page for what they're seeing in the way of oiling conditions. This could include the oil's level weatherness, its thickness, its distribution over the vegetation. Calibrating in the field is more advanced SCAT training. What they may be talking about is what they're going to do about this oil. Are they going to leave it or are they going to treat this vegetation? For operations to step into that vegetation to cut, bag, and remove it may cause more damage to the vegetation than leaving it alone. Natural recovery would be a better solution. On the other hand, if they decide that they are going to remove that oil, they would provide some constraints to operations on how they go about doing it so they don't trample the oil and vegetation and cause damages. The most important thing to understand is that the representative SCAT and the primary SCATs are collaborating together to solve a problem in the field on the shore where the oil resides. They are trying to develop both a technical solution to the problem as well as a socially acceptable one to the stakeholders. The stakeholders are those that the SCAT representatives are there to represent, such as upland land users, other businesses, and their community. As mentioned, working within the Incident Command Post, in particular the environmental unit, can be a very busy and dynamic place. There are many concurrent activities undertaken in the environmental unit other than just the SCAT process, such as oil trajectory analysis, species at risk determination, prioritizing the deployment of mobile oil recovery efforts, and nearshore booming protection. So it's important that the SCAT coordinator, the field teams, and supporting staff within the environmental unit are working as a group for reviewing coastal resource and oil sensitivity maps, establishing the operational needs to tactically function according to shore units, determining SCAT field participants and forms required, scheduling field SCAT standardization meetings, otherwise known as calibration, determining and standardizing constraints and endpoints regarding what level of treatments may be required, establishing a SCAT data management system, arranging for logistics for field transportation, and of course, most importantly, undertaking safety briefing and knowing what personal protective equipment requirements will. Many of these tasks will be explored further on in this introduction to the SCAT. Once an oil spill reaches that protracted work phase where there's no longer oiling of shorelines, the most common undertaking of field SCAT team is to go out to an assigned shoreline to observe and document and map its oiling condition, such as its distribution, thickness, and penetration into sediments. There may be requirement for some standardization or calibration of what they are seeing alongside with representative SCAT members. Collectively, they may determine that the oiling level and distribution may be at such small amounts, such as trace level of distribution, that no treatment is required, or that it's a high energy beach and that natural recovery will do a better job than undertaking treatment, or that oiling is such that shoreline treatment will be required. In that case, they will undertake the field process of documentation, mapping, and recording all that information on data sheets and taking photographs according to all the field measurement processes. Field measurement and documentation of oiling conditions of a shore is a more advanced aspect of SCAT, which is not covered in this introductory course. Meanwhile, back at the Incident Command Post, the SCAT coordinator and their team of workers are designing field survey presentations such as maps and charts for Incident Command, as well as packaging shoreline recommendation forms for operations. Meanwhile, back at the Incident Command Post, there's a lot of work that's required to actually manage the field SCAT data that's incoming, usually on a daily basis. The SCAT coordinator and assistants are undertaking quality assurance of the field SCAT data and forms for its accuracy, completeness, and clarity. They have to enter the field data into computer systems. That includes the photographs that have to be georeferenced, the SCAT information, shoreline oil summary forms, into spreadsheets and into GIS systems. They have to compile the information as summary maps and documents for command and information officers. Most important, they have to interpret all the SCAT field data and to write it into a shoreline treatment recommendation form that is totally understandable by operations. These are operations next day work assignments. All these deliverables have to be prepared and presented according to the Incident Command System operational period schedules in the way of meeting with the planning group and operations and command. The mission, principles, and core approaches to SCAT tend to stay the same. It can evolve in how it's undertaken. Examples include using unmanned aerial vehicles, or AUVs, or otherwise known as drones, to provide high-resolution close-up shoreline oiling images. These images can be annotated to show oil distribution or where you've dug your subsurface oil test pits, recommended equipment staging locations. Using still images extracted from aerial videos is an alternative to using hand-sketched diagrams. There is the employment of oil detection dogs that can sniff out low concentration of oil at trace levels, as well as oil that's buried under sediments. These are referred to as the canine SCAT. When there's very low amounts of oil at trace levels, you could bring along a few operational team members to accompany you and clean up this oil and bag it as you're doing your shoreline assessments. This avoids operations coming back to the shoreline for such small amount of work. It's referred to as Clean As You Go, or CAYG. As a preparedness initiative, much like establishing geographic response strategies on where and how to set up nearshore booms, one can undertake a process of pre-SCAT and do a lot of shoreline documentations prior to an oil spill. Pre-SCAT is examined in the next few slides. There's also the option to use tablets to gather SCAT data collection rather than having to write out forms. This also facilitates downloading the data into spreadsheets and GIS systems. As you progress through this course, you find that making a SCAT decision of whether or not to treat an oil shore and how and when is much more difficult than actually doing the work itself. Though there are many SCAT manuals and guidelines to reference to help you make a decision, during an oil spill it's not the time to actually review them. Canada's SCAT manual itself is over 100 pages long. In recognition of this, there have been some SCAT decision support tools developed, such as Owen's Coastal Consultants Feasibility Analysis for Shoreline Treatment, known by the acronym FAST. This aid recognizes that there's over 50 different types of shoreline treatment measures that could be applied to 40 different types of shorelines. In reality, when one assesses an oil shoreline, there's generally only one or two treatment options that are feasible, if they're required at all. Once the most feasible treatment options have been ascertained, then the SCAT team determines what are the concerns and trade-offs pertaining to potential consequences, such as how much waste is generated, whether it's cultural and ecological impacts, or the time and effort that might be involved, logistics, and overriding safety to the workforce itself. The FAST decision tool is a field application that can be referred to at the shore being assessed. The key to having a field-based decision tool is that now you have a means to having structured collaboration with representatives engaged in the SCAT process and assessments, rather than just relying on the word of a SCAT coordinator or lead. The shoreline component of an oil spill response involves the greatest resource commitment in the form of effort, time, and cost, and continues far longer than the high-profile on-water oil recovery phase. The initial response to most oil spills has, and appropriately, been focused on controlling the source and containing or removing floating oil. Typically, attention does not begin to shift to the shoreline response until after a shoreline has been oiled. Shoreline response planning has been assigned to the environmental unit with the implementation of strategies and tactics to the operations section. On occasion, this has resulted in accountability and communication issues. A shoreline response program provides a single source for information and the data related to shoreline impacts, treatment recommendations, tracking the progress of operations, as well as creating direct communication links between SCAT, the environmental unit, incident command, and most importantly, field operations supervisors and crews conducting the response activities. The Shoreline Response Program is a paradigm shift that creates a management culture and planning and preparedness structure to elevate shoreline response to a higher priority and level of support within the current organization of an incident management team. For preparing ahead, there is an opportunity to undertake SCAT before a marine oil spill. This preparedness is referred to as pre-SCAT. It could be an aspect of Tier 1 local response capacity building, such as for a First Nation. Basic shoreline information can be compiled in advance. If you look at SCAT fields data forms, it is mostly about the receiving environment, such as substrates, exposure, ecological and commercial and cultural sensitivities. The rest of the form is about oil itself. Pre-SCAT recognizes that it's practical to collect and assess shoreline information, then compile it into a database and map and photographs before spill, rather than under the time constraints and dynamics of an environmental emergency. There's a higher likelihood of achieving a net environmental benefit and scoping out treatment methods and what level of treatment would be required in the form of endpoints. Initiating a pre-SCAT program is an excellent training opportunity for preparing for a marine oil spill. When one looks at coastal resource and oil sensitivity maps, one realizes that there are thousands of shorelines that could be affected by an oil spill. An example of such coastal maps is those developed by the U.S. National Oceans and Atmospheric Administration's Environmental Sensitivity Index maps that show vulnerable and sensitive types of habitats and uses to oil spills and chemicals. This chart sort of models a process of making a decision on which type of shoreline you might want to take the time and effort to pre-SCAT. There are two streams. One is to look at it from a representative standpoint. The second is to look at a special area. Taking a representative approach enables response planners to extrapolate what treatment options and operation constraints might be applicable to other shores within an important high spill risk area. An example would be a typical West Coast estuarine marsh area. Another may be a shell hash beach that represents the middens of First Nations. For special areas, pre-SCAT can be part of spill contingency planning. For facilities such as a oil loading terminal or a logging camp that stores oil, with some basic oil spill trajectory modeling, you can determine which shores could be impacted by the oil. These would be selected for a pre-SCAT. Undertaking pre-SCAT for potential places of refuge recognizes that vessels may have to beach or be directed to a place of refuge to stabilize the situation. The vessel requesting assistance may be actually discharging oil, or there's a threat of such a discharge. Pre-SCAT provides an opportunity to prepare ahead to mitigate damages for this special area. Following is a demonstration of pre-SCAT, just to give a flavor of the process and not get into the details, which would be intermediate and advanced SCAT courses. These shores are within an area of concern that has been identified by a coastal First Nation and in particular one of their reserves. The first thing to observe that the image was taken by an unmanned aerial vehicle or a drone. Both video and still imagery is part of the shoreline documentation for pre-SCAT. Next is that you note that the shoreline has shoreline unit numbers and that these correlate with the shoreline coastal map insert at the bottom. For SCAT, it's imperative that all data is linked to a shoreline unit. Shore unit reflects its geomorphology. Shore Unit 67 is a rock cliff, whereas Shore Unit 68 is a sandy beach. If you want to view a video narrative of walking down this shoreline, there is a YouTube link above. The video was done by a 360 camera. This is another form of technology that supports pre-SCAT documentation. Though the coastal map shows Shore Unit 68 as a sand beach, it's actually a sand and shell hash. The shell hash is a remnant of a midden. As well as from the aerial video, you can see that this is an abandoned village site. Right away you can tell that this is a culturally important area for First Nations. From the aerial view, you could tell that this is also a protected area. If the oil was crude or a heavy residual oil, such as a bunker oil from a vessel, its retention time would be months to years. Owing to this and its cultural significance, shoreline treatment would certainly be a viable consideration. The access and egress to the shoreline is pretty straightforward, as being a sandy beach with a low bathymetry, but there would be limited space to stage equipment on the shoreline. During an actual spill, there might be a First Nations monitor on site to make sure that the operations did not go upland into the village site itself. This is the type of information that is captured on a pre-SCAT form. Pre-SCAT, you actually take a lot of images. This image shows that the primary substrate is sand with a veneer of shell hash. Sand generally has low penetration of a heavy oil, particularly if the sand is wet. Sand has good bed loading for worker footing and equipment. That is, people and equipment don't get mired down in the substrate. The veneer of shell hash is a bit problematic insofar as not flushing it or digging it away with oil removal. This is the time in which we reflect upon how to solve that issue. A test pit would be dug to determine the depth of the sand and what it's overlaying. There is a safety factor present. There is broken glass, which are remnants of the village occupation. The treatment method would be recommended, and there may be several steps in achieving treatment. What level of clean would be considered, which is referred to as the endpoint, and how to deal with oiled hash would also be considered. Again, this would be noted on a pre-SCAT form in the form of both data as well as annotations. This is a close-up image of shell hash, primarily in the mid and upper and supertidal zone. They are derived from the erosion of the backshore and upland middens. The naming and determining of these types of zones along a shoreline is part of intermediate and advanced SCAT training. Contamination of these shells with a heavy oil and deep penetration would be very problematic in treating. They are a light substrate, though situation specific. To undertake ambient water flushing, or to bag and remove it manually, or just to leave it, are some of the options. Treatment methods for specific substrates and situations, again, is intermediate to advanced SCAT training. We're now moving out of Shore Unit 68 into another shore unit because the shoreline geomorphology has changed from a sand beach to a rock platform. You can see remnants of a tombolo, which is vegetated midden materials. As with Shoreline Unit 68, Shoreline Unit 69's coastal character is vegetated. Naming shoreline types and coastal character is advanced to intermediate SCAT training. SCAT uses very specific terms for what you see and record on forms. As you go around the headland and behind the tombolo, you see that Shoreline Unit 69 is very complex. The headland, as a rock platform, has interstitial sand and gravel mixed in it. Then you come around a short section of shore with sand, and in the upper intertidal area and supertidal area, a thick layer of shell hash. And further down the beach, you'll come across shoreline with pebble and sand with boulders scattered throughout. By digging pitch, you'll find out all this material overlays bedrock. Bedrock is a natural barrier to oil penetration. There can be different types of treatments throughout this shoreline unit. As such, you might want to separate this shoreline unit into 3 different units, according to treatment strategies, and different endpoints for cleanup. Breaking up a shore into more segments is advanced SCAT training. For every shore being assessed, there's somebody capturing this information on a pre-SCAT form. SCAT field forms can be quite complex. Nevertheless, they are telling you a story. Understanding and completing SCAT forms is advanced training. Completing SCAT forms is not the end of the job. When you return back to the office, you have to manage all your photographs and make sure they're annotated and relate to the shoreline that you're working on. You have to review and edit your drone imaging. For example, you might want to extract the best still image from the video of the shoreline that you just assessed that can be used to be annotated in the event of an actual oil spill, showing where your test pits are, oil distribution. You have spent a lot of time and effort doing these field assessments, so you need to establish a systematic filing and information retrieval system for all your data, your forms, your pictures, your videos.